review as a part of phase 1 assessment, right? So records not only of the site but of adjacent site as well. Thank you. Compensation for mistakes, as we talked about earlier. The information should be reviewed, should be from standard sources which are publicly available information, libraries, records of information that are kept with the pollution control boards, environmental, other regulatory bodies, information obtained from the sources within a reasonable period of time, and cost. So don't go into a deeper stuff where the information is very obscure, cannot be found. The data should be practically reviewable, and it should be relevant. You can use alternates to standard sources as well, like newspapers and so on. Supporting documents should be a part of the report. Additional environmental record sources should be reasonably ascertainable, or in a reasonable time it's accessible and sufficiently useful. A geographical survey 2.5 minute topographical map is very useful. Should look at groundwater maps, bedrock geology maps, surficial geology maps, soil maps. You should look at all obvious uses from present until up until 1940 or so. So in certain places it might be even later than that, but all obvious uses. Okay. The purpose of this one is to establish whether there is activities that have happened, where have the activities that have happened, and what are the consequences that one can expect. Okay, this is not phase 2 is built on a phase 1. When you do a phase 1, give a report, it is the report that the phase 2 guys then take and then come up with a plan to dig and find out. Okay, so you should look at things like fire insurance maps. Okay, fire insurance maps means maps that have been done. Now fire insurance maps are insurance companies are very good in keeping records. Okay, they're usually very good because when they have to pay out, they have to pay out big, so they keep out very meticulous records of it. So if there are insurance maps which goes back in time, they'll tell you what is the developed use, like what use has happened in certain areas. Okay, so there was a shed here. The fire insurance guys are covering for insurance, right? So they need to know what was there. So let's say in 1970 there was a shed there. When you go there, there is no shed, grass has grown, there's nothing you can see, right? But that fire insurance guy map will tell you that there was a shed that they insured. The question is, okay, what did they do in the shed? What were the activities that were carried out in the shed? Okay, so the use of it. You should try and review information at 5-year intervals, because there might have been a shed in 1980 or 1970, it was removed in 1980, now there is nothing there. So if you actually don't go back in time, you will not be able to see that there was a shed or a drum or a pad or something, right? Find out and be specific about uses. Remember, you are going back in time. You will have lots of difficulty actually finding information. The employees, if they are there, and retired employees, that's great. We will talk about that in a bit here. But there might be data gaps, right? Like there is somebody who has kept records, then there's a period when there is no record, and then there is another period, let's say from 70 to 75, there is some record, but 75 to 80, some guy worked there, nobody knows where the records are, and then 82, 83, some other fellow shows up and he has started taking some other records. There are some handwritten notes, and then maybe in the 90s there is some computerized records. So it's all over the place, right? Use of surrounding areas. What was the surrounding area used for? Okay, what not only that particular area, but what did the neighbor use this site for? Okay. Look at aerial photographs. Now aerial photographs are taken every so many years. The government flies these planes to take photographs of what the area looks like. And these photographs are usually stored in the local libraries every 5 years or so. Okay, so if you go, you can see that there is this in those previous aerial photographs, you can see there is a drum here, there is a pad there, there is a shed there, there was this there, there was that there, and maybe in the subsequent one you might find that the pad is gone. Now there is a building there, or the building is gone, the pad is gone, there is a nice flower bed there, right? So you will never be able to tell just by looking at from today's perspective, but you have to go back and take a look. Fire insurance maps we talked about. Property tax papers. Okay, like if the property tax is determined based on the use of that place. Recorded land titles record. Who owns the place? Topographical maps. Local street directories, building department records, zoning, land use, things like the insurance guys. If you're talking to the insurance, you want to find if there's an insurance claim, if there was a fire, then there was an insurance claim, or there was any kind of an accident, there is an insurance claim, right? You would know what they will have records of what exactly did they do. Local newspapers, sources, going back in archives, archival sources. And okay, so that is as far as the record goes. So you will start with a record review. Okay, this is how you will do a record review. Find out what happened historically, find out what structures were there historically, find out what activities would have happened if there is a pad, a shed, what exactly happened, if you can find from the records review only. Okay, if there is a newspaper article in the 1985 and said that there was a fire in this particular area, or whatever, there was an accident, and what was the accident about, what spilled. Okay, then what you will do is site reconnaissance, which is just walk around the site. Okay, nothing like seeing, take it from me, nothing like seeing. If you can go to the site, spend the day, spend the next, if you have to, and walk around the site. Okay, you see things like where is the road? I mean, the road is where they will bring the trucks in, right? If there's a spill from a truck, or if any hazardous chemical or anything that has been brought, it's usually brought using a road or a railroad. You need to know where the railroad is, where the road is, right? Adjacency, like you'll also look at the site interior structures. You walk into an old empty building like this, just walk in and see. He'll tell you there is a distress there, maybe there is a stain there. Why is there a stain just in that location and not in any other location? Why was there it looks like there is a smell here. Those things. Conduct a visual inspection. See, walk through it. So if you walk around, for example, if you walk at the back of the building and you see that this is a long building, you walk inside and you see this wall. Can happen, right? There was something that was stored at the back, somebody put a wall, and later on somebody put a paint on it, and now we don't have access to it. With time, things change. Okay, there's no way you can say why something happened, but it happened. Okay, so when you look at outside, it looks like a long room. Inside, you only get a part of the access. So what is behind this? Is there a way I can access it? Maybe there are just drums behind it that somebody had put. This was a barrier, somebody put a paint on it, it's old waste materials, and they didn't want to show it to the authorities or to themselves, so now it's behind that wall. You would miss it if you don't think about the length that you see from outside and length that you see from inside. So usually if you have a trained eye, one site visit is enough. Okay. Look at site use and conditions. What do they use the site for? What are they doing today to that site? Okay, what is going on in that particular location? Okay, where are they storing the hazardous material? How are they storing the hazardous material? Right. Look for unoccupied occupant spaces. That's what I said. Things like blockages in the pathways. Past use of property. Okay, what was the property used for? Usually they'll be able to tell you this was a refinery, and in this refinery, we did this in this location, we did the other this in this location. Now, by following the process of how the chemicals move, this is where the truck came and brought my chemicals, this is where we stored the drums, there was a pad here, now we don't do it. Or we do it, right? Now, we know that if some activities had been carried out in certain places, there is a good chance that things would have leaked in those places. It is also possible that they may not be able to tell you all that, because the current owner may not know. It's not that they're trying to hide, it's the fact that they may not know. The old owner of the place has either moved on or died, whatever, and then now you have new set of owners and they're trying to do things differently, and things have changed, right? Technology has changed, the whole operation might have changed. You also should look at, this is still a part of the walking around on the site. You should also look at adjoining properties. What did the guy, what happened in the properties along the side? What are the past use? Did they do something that might have an impact on your site? Remember, that particular property might also have changed land hands, right? Current and past uses are, you should look at the geologic, hydrogeologic, hydrologic and topographic conditions. General description of structures. If you see distress in the structure, stains, if you see things like part of it has fallen, why did that part fall? Okay, is that because there was too much load? Let's say this is a building, okay, and you find that the roof had fallen in that corner there. The question is, why did that particular roof fall and not the others? Did they store something on top that eventually made it collapse? Or, is there a structural issue or is there an environmental issue? Right? So those are the things. What are the sources of potable water? Where was the water coming on this site? Because that's one of the things is the water might, if there is, for example, a hand pump somewhere, and if you have this thing, the hand pump will drain the water, which will cause it to the groundwater and then eventually go, right? So those things. Sewage disposal systems. Typically, in the olden times, people would just dispose whatever hazardous chemical they have down the sewage, the toilets and sewage and so on, right? Just put it down. It's the same. So sewage disposal systems are a good location to try and find out things like pipes. Right now, the sewage disposal might have changed. There might have been a hole in the ground. Now that hole in the ground has been replaced by a proper toilet. In which case, it may not be in the same location. Things for storage tanks, above ground, underground, vents and pipes. If you have an underground pipe, which quite often, if you have an underground pipe and if there is a leakage, the hazardous chemical will move through that pipe, either in the pipe or adjacent to the pipe, because when you install a pipe, you put a sand around it, right? So just so you don't have water pressure build up, so it might move along with the pipe. That might be, so you might have a contamination here, but then it's moving on the pipe, so you have to make sure that you identify that entire area, right? Pools of liquid. If you see a pool of liquid somewhere, whoa, where did this come from? Okay, there's a little area where you can see some liquid, and then what is the source of the liquid? What is the liquid comprised? Remember, you're still not doing any intrusive test, so you're not exactly sampling that liquid, but you have to make a note of that there is liquid there on site. Drums on site. In an old site, you may find a whole bunch of drums on the side. Right? There are 30, 40, 50 drums, and half of them are empty. Okay, make a note of it, because the drums would be carrying something, which of course will then lead you to something that hazardous substances in petroleum containers, unidentified substance containers. If you find that those drums have no label, they're not telling you anything. You can't smell anything. You can't. But there's no label on it. Okay. But make a point of noting that there are some unidentified containers. Electrical and hydraulic containers containing PCBs. Heating and cooling of the building. Stains and corrosions. Drains and sumps. Pits, ponds and lagoons. Stained soil. Yeah, this is the other thing. If, for example, if you walk around and if you find it's nice green grass, but then a portion has got this brown grass, distressed vegetation. Why is it distressed? Ask these questions to yourself. Why should this particular area be distressed? Okay, maybe there is something seeping from the ground up, killing the grass or not letting the grass grow, causing it to remain distressed, right? Maybe something was there, it was removed, but the grass never got the nutrients it needs to actually grow. Therefore, that area is distressed. So, stressed vegetation. Solid waste, which is garbage, how did they dispose it? What wastewater? If you have a septic system, if there is a well, note those things. Many times, they used to use the well to if it is not a water well, it's a hole, then they would use that to dump all their waste chemicals. Okay, so that's your site reconnaissance. So first you do record review, so you have got a reasonable idea what the site would look like in historic terms. So as you walk to the site, you have that images in your mind. I remember there was a drum here, I can't see it, it's all gone, but I remember. So you walk around that, see when you go to that site, after a good records review, you have a reasonable idea of what it looks like. Okay, and then you do the site reconnaissance on what goes on where. The third is interviews. Okay, talk to the owners, the present owners. What did you do? How did you do? Where did you do some things? Okay, find out the past owners. When did you buy the site? Oh, I bought it in 2008. All right, that's 10 years ago. But who was the previous owner? The previous owner was this big company. Okay, track them down, talk to them. Okay, what did you do? Where did you do? How did you do it? Tell me about your operation. Even a phone call will do. Okay, and they should understand that there is a legal responsibility for them to tell the truth. Okay, this is serious business. It's not you can't just bluff your way out of it. So once they understand that, they will start. Okay, so you talk to the key site managers who manage the site. Okay. If there are less than 5 occupants, so if a site is divided into different parts, and if you have pretty much one representative from each, if you have more than, if it's a massive site and there are like 10-15 occupants, then maybe some of the major occupants should be discussed, should be talked to. You should talk to previous employees, right? If you can access them, they are usually willing to talk. Okay, but keep in mind there might be a reason why they are willing to talk. Okay, they might have a grudge against that company. They might have a problem, and they might have lost their job, and they might have a grudge. So you will have to tease out. You will have to separate the truth from exaggeration. That will be your job. Okay, your job is to find out what happened. So otherwise, this guy was really bad and did this and did this. It might just be fiction. Okay, and you don't want to be chasing a fiction here. So you will have to corroborate that with multiple past employees. If you can tell that the stories are intersecting in somewhere, and this is what happened, and we used to dispose this. अरे हम तो वहाँ पे उस well में हम सब डाल देते थे. Everybody would say. The other guy will also say, it was all known. Everybody put it in there. Now you know that well is a problem, right? And now you have marked it as a potential source to do a phase 2. Remember, you don't want the phase 2 guys to come and do a phase 2 on the whole side. They are relying on your judgment to identify what has happened where, to be able to more or less identify the area where contaminated activity would happen, so they can then show that by actual sampling that's happening or not happening. Do you see what I'm saying? So that's the purpose. Registration of underground injection systems. If you're injecting something, material safety data sheets, reports of hydrogeologic conditions, This is the other one, correspondence with government regarding past or current environmental violations. Okay, like if the Pollution Control Board had put a fine in, I don't know, 1971, a fine for whatever, 50,000 rupees or something for doing something, right? Then you know that they have done something, then you can find it because there is a record of that somewhere. Okay. Geotechnical studies, if there is any studies that has been done on the site by the current owner, the past owner, or someone, right, like what is the soil condition, that will tell you how far the contaminant would have gone. If the soil is sandy soil, water table is high, you are looking at some trouble here. If your soil is clay soil, well, it may not have gone that far, or the water table is very deep. If somebody has done a risk assessment in the past, okay, if there is pending or past environmental litigation, okay, if there was a in the past somebody had sued the company for because it impacted their health, either a worker has sued or a neighbor has sued or something, I'll tell you that, okay, what they're suing about, because the court documents are public, you can access it and you can say, okay, you can see what had happened there, right? Administrative proceedings related to hazardous substances. This is basically the Pollution Control Board might have put some administrative controls like thou shalt do this, right? Notice from government regarding possible violations, so on. Interviews with local fire department, okay, because if there was a fire on site, if the fire people have just called even for a small fire, they would have records of it. Local officials having hazardous waste disposal jurisdiction, if somebody was called for how to dispose of, okay, we got these 3 drums which contains X chemicals, how do we dispose of it, right? Building permits, that's another one. Were there building permits drawn on site? So if you walk to a site, you find 2 small sheds, nothing much. Now, but you see, go back in history and you find, okay, they had a bunch of building permits. What happened to those buildings? Did they have the buildings and then they pulled it down, or they never built the building? That question should come to your mind, right? It only will come if you get the building permit. Based on all of this, now you have done the site, the records, you have done the interviews, you have done the reconnaissance, and now you've done the interviews. Okay, this time there is nothing much for the site that should escape your eye by this time. You should have a good idea of what the site is. The activities that has happened over the last 4 or 5 decades, where the things have happened, what things have happened, where, and now you should write your report. Okay, you will have to distinguish in fact and fiction, what is true and what is untrue. Remember, people's memory has a funny way of distorting facts sometimes. Okay, we all go back and think things which may or may not have happened in that time. Some of it gets colored by our own judgment, some of this just by fact that it's been a while and what I'm recalling is different from what actually happened at that time. Okay, so all that has to be somehow distilled into fact. Identifying areas of actual potential and the basis for the findings. So this is where you would have to say, okay, I think this is what has happened here, and this is the reason I think that is what it is. Identifying the degree of uncertainty. So that's also an important thing, because the phase 2 is going to be based on phase 1. You have to identify where you are certain, right? And what is your level of certainty? One guy said something, the certainty is not high, right? But something to note. That guy might be telling the truth, might have a good memory. The other guys didn't bother to mention it, right? So, identifying potential receptors at risk. Okay, so if there is what is the adjacent? For For example, if this is a site and there is some activity going on here which can cause fumes, okay, and there is a daycare next to this site, it's important that you identify that. Look, there is a daycare next to the site. I have reason to believe that there is this thing. So it drives the importance in that direction for the second phase. Are you with me on that? Recommending whether, so this is the key thing, okay, the recommendation whether a phase 2 is required or not. That's what the client is looking at. So your phase 1 should say, based on my entire analysis of all these reconnaissance and looking at the site and talking to the interviews and reviewing the records and all, I think a phase 2 is required, and this is where you need to do it. Okay? Or I don't think a phase 2 is required. I don't think any contaminating activity was going on here. Okay? If you say a phase 2 is required, you are expected to say what needs to be done. Okay? So while the phase 2 guys are going to take a look at it from their own perspective, they are not going to review the records or talk to the previous owners and all that stuff. They're going to take your stuff and then maybe have some discussion internally, but they will start doing the phase 2. Are you clear on the phase 1? Do you think you can do a phase 1 based on what I told you? So normally in my course, when I teach this thing, I give them a bunch of sites and I ask them to do a phase 1, a phase 2, a remedial planning, and a remedial action. The whole thing, that's a project. That's the course project. You do a phase 1, and in an interview and all, you have a client and a consultant. You interview each other. I give a lot of data. So what I do is, I say, okay, and then you come and ask me for the data. I'll give you some data, and then you do a phase. That's your phase 2, because obviously you can't do a phase 2, right? So I'll give you some data, and then you go and design a remedial system. So that gives a little bit of a practice. Unfortunately, here we don't have that luxury of that much time. But do you know enough to do a phase 1? It's basically just if you wish, I can take out an old site if I find, and then we can work through it. But the problem is the time again. But something to think around. Okay. Okay. So that's your phase 1, and then you will report. You will report your findings. You will report whether conclusions should identify whether no evidence of contaminating actions, evidence of potential, evidence of actual and potential. Okay, then you come to what is known as a phase 2, environmental site assessment. In phase 2 is basically sampling. Okay, and there are 2 steps to it. Even in phase 2, there are 2 phases. Okay, one is the initial screening level, in which case you want to make sure that the guy who did the phase 1, the person who did the phase 1, even though they use the best judgment, if there is anything there or not. Okay, so that's your initial cut. So if I, for example, if he says there were drums there, I'll take maybe 2 samples and send it to a lab and see what happens. If I find nothing, then I start questioning. Maybe there were drums, maybe there were drums but it never leaked, right? In which case it's not a problem. Or maybe the drums are not there, right? So whatever. So I start. So that's your initial screening level. This is followed by detailed site assessment. Remember, as you go from one phase to the other phase to the third phase, you are looking at orders of magnitude increase in cost. Okay, so I can give you some numbers. Unfortunately, they are in US dollars or Canadian dollars, but you can relate to what I'm saying here. The cost of a phase 1 will be a few $1,000s. Okay, maybe $4,000, $5,000, $8,000, that kind of a number. The cost of a phase 2 will be one order of magnitude higher, maybe $30,000, $50,000, $80,000, because now you have to bring a rig, you have to drill soil, you have to take the soil, you have to bring the soil back, send it to a lab, you have to do a screening level. Then if the screening level comes, numbers come, then you have to send a detailed assessment, all that. And there is a bunch of other analysis too in phase 2. And the remediation will be another order of magnitude higher, maybe $300,000, $400,000, whatever, right? You can see how the cost would increment from one phase to the second to the third. So expectation from a phase 2 is no reasonable basis to suspect a substance release. After phase 2, you will find no, there is no reasonable reason to believe that there is any kind of contamination has happened, or the assessment has confirmed a substance, a specific substance of release. The uses of phase 2, because what do we use a phase 2 for? Remember I talked about site characterization? This is phase 2. You want to use it, you want somebody to tell you at the end of phase 2, this is the contamination, this is where it happened, this is the geologic condition of that site, this is where the water table depth is, 5 meters from the surface, 3 meters from the surface, the soil is clay loam or whatever have you, it's petroleum, it's whatever, right? You need all that. This is the area, not all over the map. This is the area, and this is the other area. Here it is metals, here it is hydrocarbon. You need all that information, because then the next stage is the cleanup. And as I've been telling, you don't want to clean soil. You want to be cleaning only dirty soil. And the less the amount of soil that you have to clean, because the better the characterization, the less the amount of soil you will have to clean. Okay. So the prepare for remedial investigation to further interpret the findings of a phase 2, to further interpret the findings of phase 1 and supplemental information from a previous. Yeah, so the other one is sometimes what happens is there has been a phase 2 done. Let's say somebody has done some, let's say I'm an owner and I have done a phase 2 and they haven't found anything, right? But 5 years or 7 years later, I find that there is reason to believe that my neighbor is complaining that I'm contaminating their well or something, right? So there is an existing phase 2, right, from before. Then you will do the second phase 2 to supplement the information from the previous phase 2, right? Because you already got some actual data from the ground in the past. So what are the study objectives of a phase 2? Confirmation of a phase 1 ESA. Identifying contaminants that are present. Remember, it can be anything, right? It can be diesel, it can be gasoline, who knows what is there, right? Especially in areas where they used for disposal of waste product. You don't know what they disposed of, right? Metals. Develop a conceptual hydrogeologic model. Okay. Now, some of you are doing contaminant transport as a part of your thesis, right? This is where your contaminant transport model fits in the broad scheme of things. Okay. Think of about what is the purpose of a contaminant transport model. How many of you are doing contaminant transport model as a part of your thesis? 1, 2. There's more than 2, I'm sure. Come on, be bold. 2? Only 2? Only 2 brave ones? Yesterday I thought there were half a dozen. Maybe you changed your topic. Anyway, this is where it fits. This is where, in the broad scheme of things, and this is what you should think about. Why are you doing a model? Why are you doing a contaminant transport model? For the 2 brave ones, let me put you on the spot here. Why are you doing a contaminant transport model? What is the purpose of it? Right. So you see where your mind has to be. Your mind has to be in, okay, I have to remediate it. So it's not just the mathematics of it or the physics of the transport, but understanding how the model is going to, or sorry, how the contaminant is going to migrate, so that you can take precautions. What is the advantage of doing a model? What is the beauty of doing a model? I can tell you a lot of complexity, but why do you have to model it? That's a tough one. Yeah. Source. So you don't know the source at all, right? So do you have a phase 2 report to back? So but you have groundwater data. So why are they doing a groundwater monitoring without a phase 1 or a phase 2? On what basis did they start monitoring the groundwater? No. You are getting into complexity of data. I don't need to know the process. Here is my question. Why is somebody monitoring the groundwater and contaminant level without knowing that there was a contaminant? Do you understand what I'm saying? You don't have a phase 1, you don't have a phase 2. Why are they monitoring it? So the landfill is the source. Why are you saying it's an inverse problem? Right.
There can be a number of sources.
Right. But is there a reason to believe that there will be another source? Right. All I'm trying to do is to make you think that there, it may happen that you don't have access to those reports. Somebody is not giving you access or whatever, right? But you don't start monitoring one day, chalo dekhte hain kya ho raha hai, right? You have to, there is a reason, and that reason is usually this. And this will tell you a lot. If if you happen to have it, the source might even be there. Even in your inverse problem, you cannot randomly look for the source anywhere in that area. You will have to, yeah. So that's what I'm saying. You just see if you can find the report, or you can ask the same question I'm asking you. Is there a, or why did you start monitoring? So yeah, this is where the model fits in. So keep that in mind. Quite often what happens is we get so caught up in the numerics of what I'm doing, the little nitty-gritty details, the uncertainty analysis, the porosity, the thing and that we forget or we miss the bigger picture. Keep the bigger picture in mind, right? So this is where you have to develop a conceptual hydrologic model, identify the properties of the media, the soil properties and so on, measure the concentration of each contaminant, drill boreholes, take samples at different depths, take soil samples, take groundwater samples, send them to a lab. And now here is the other problem. If you send a sample to a lab and say, tell me what it is, how will they tell you? Right, and how will they analyze? Louder? pH. You said pH? Did I miss it? So basically they have to analyze every single thing, right? They don't know what you have. If you have no idea, then your chromium or cadmium or mercury or lead, and every single analysis, an independent analysis, will cost you money, right? It is much better if you can tell them, these are the 6 of them that there is a good chance. Let me know whether any of these is present and how much, right? Therein, and they will then focus on those rather than trying to measure everything under the sun. So, and then understand the fate and contaminant transport mechanisms. Like how is it moving? What is the move? This is a part of the phase 2, and that's why it is expensive. It is not just taking samples, but also analyzing the samples, making sure you have the profile of the transport in the because that's how he will remediate the site eventually, right? You want to be on the pathway of it is moving. So this is an example of a plume delineation. Okay, there was a pipe break here. Okay, there's an unsaturated zone with liquid crude going into the saturated zone. The water table is moving in this direction, and this thing is moving in that direction as well with that water. Okay, this is an example of how you would eventually be expected to come up with. But to come up with this something like this, you have to come up with the monitoring wells and monitor the data. Okay, what did I do? Okay. Did I miss it? Sorry. So phase 2, you have to review existing phase 1 ESAs, previous phase 2s if they exist, plan a site investigation including sample plan, conduct site investigations, interpret and evaluate data and report. Okay. Then you develop what is known as a conceptual site model. What does the site look like? It's when I say site model, it doesn't mean it's a mathematical model. The mathematical part is a part of the whole thing, but a conceptual site model, it's got undulations here, the topography is here, there's a trees there are shrubs there, all that, land use description, what was the land being used, which portion is used for what are the regional processes. Regional process means how are the groundwater flowing regionally, right? You own this little site, but the groundwater might be flowing from northeast to southwest regionally, right? So site investigations, contaminant characteristics, potential exposure pathways, receptors. As we talked about earlier, maybe the neighbor is running a daycare or a school or elementary school or whatever. Now you see the receptors that might be present, especially if you have vapor phase, and then summarize everything. Okay, that is your phase 2. still not done yet, phase 2. Okay. So you then have to do sampling. Remember, your phase 1 has identified, you have to now sample. Where will you sample? You have to identify the sampling locations. Depending on phase 1 and depending on the site, conceptual site model, you'll have to then identify the analytical parameters. What do you want to measure? Right? You cannot measure everything under the sun. And if you do want to measure everything under the sun because the phase 1 was not able to identify anything, right? So let's say if there is a refinery, that much you would know, right? It was a refining activity. They're not telling you, okay, what did they put, but you can look at, okay, in the 1970s, what was the process did they use for refining? What are the chemicals that are used for refining? What are the chemicals that are brought on site? Okay, if you look at the general process of refining that happened at that time, you can narrow down some of it. It will not be like anything under the sun, right? And you narrow it down and then you try to develop some analytical parameters, some non-intrusive testing, some intrusive testing. Non-intrusive testing is like ground penetrating radar, GPR. You want to find out if there is a pipe underneath buried somewhere, right? More, you know, these nobody has, they may not have these maps of piping underneath. You know, they had built this structure underneath. At some point they changed, they modified the whole thing. There's a piece of pipe lying underneath. Nobody knows, and it has not been used since the late 70s or mid 70s or whatever, right? So this kind of a thing, the non-intrusive testing will tell you. Intrusive testing is things like soil sampling, water sampling, QA/QC. This is very important, QA/QC, because remember, anything that you do should be defensible in a court of law. You have to have that level of preciseness, because at the end of the day you will give a report and you move on, right? You will have to move on to another project. So somebody might read this report 2 years from today, 3 years from today. The guy might be trying to sell the land, and now a different consultant from the other side might be looking at your report and might be challenging your findings. So you have to be very careful how you do it. So QA/QC is, for example, on the lab side. Okay, like if you take a sample and send it to a lab, you want to make sure there's a chain of custody. Before you actually go to the field, you have to prepare for the field. You have sample bottles lined up. If you have a, for example, how do you preserve the samples on site? Right? There are processes to follow. How to preserve the sample. You take a sample from the site, you're supposed to filter it, and then if it's, for example, if it's metal, you might add a little bit of acid to keep it in suspension, and all that has to happen on the site. Then bring it lab, store it. There's only a small period of time you can store. You cannot store it forever. Okay. Remember we talked about the headspace issue yesterday, right? Those things, you know, you want, if it is a volatile that you're collecting for, you don't want any headspace. Okay. Things like plastic bottles versus glass bottles. Does the organic photo degrade under sunlight? You take a nice glass bottle like this, and it happens that it degrades in sunlight. You leave it in the sunlight, go for lunch, come back, maybe a portion of it got degraded out. Or if it's plastic, it might bond to the plastic. So there's a whole QA/QC for field operations that you need to be aware of and follow. Okay. Keep in mind, whatever you do, 5 years, 10 years later, you should be able to look back and say, this is what I did, and it should be defensible. There should be no, I don't know what I did, kind of a thing. Okay? Because you might be challenged, and that can be a So regional and site characteristics, substance release, proposed soil sampling analysis, schedule and soil quality guidelines, NAPL, El NAPL, we talked about it yesterday. I'm going to keep moving here. Okay. Okay, preparation for site investigation. Actually, now you're going to the site. You need to have a health and safety plan. Okay, you want to make sure that all the workers, whether yourself or your people who are going to assist you or your subcontractors, all have follow the health and safety guidelines that are needed. Utility corridors, things like electricity and water and so on, where they go through the site. The CSM we talked about are at hand. Contaminant sources and types, NAPLs, groundwater pathways, all that you have worked out beforehand. Okay, this is just another example of a VOC going through the cracks in the house. Okay, soil sampling and analysis. And groundwater sampling. For soil sampling, you need the location and the depth. When you are doing soil sampling, you also should do the groundwater sampling at the same time, unless you are just doing soil sampling on the surface. You're going scoop. So here is the other thing. Do you want to use a scoop, or do you want to auger it down? Huh? How? How will you establish groundwater flow direction? Why do you need 3 wells to establish groundwater flow direction? Minimum of 3 wells. Yeah, how will you find out? How will you find out which direction is it moving? So you measure the depth. Okay, so this is what you have to do. So you need a minimum of 3. Let's say you got 1 and 2 and 3. Okay. Let's say you find that the groundwater from the surface here is 5.2 meters. Okay. Let's say you find here it's 4.9 meters. Okay. And let's say you find here is 4.7 meters from the surface. Okay. How will you find which way is the groundwater flowing and what is the speed? Here, take the chalk and tell me how you're going to find. Come on. Right. Come on. Don't worry. This is all a class, so don't worry. You want to try it? I'm giving you as much information as I have. Those are the elements. So this is the from the top down, that's the surface. That's all you can measure, right? If I have a well, the rest of you guys think about it, okay? You never know, I can call on you, so don't get too comfortable in your seat. Let's say you got this is the water table. All right? This is all I can measure. I can put a line down from the top and I can measure this one, right? Let's say I measure this is 5.2 meters in that one. Okay? And the depth to bedrock, and let's say the bedrock is here and this is let's say 10 meters. How will you find the direction and the groundwater flow? Anybody else? Yeah, come on. As you know, we are struggling here, so don't worry. Just don't worry, because को तो नहीं आ रहा. Huh? Don't worry. So please take a seat. I'm not. The intent is to learn here. I just want to see what. तो कहाँ किस तरफ जा रहा है पानी? मुझे मेरे उसमें बताओ ना किस तरफ जा रहा है, मैं ड्रॉ कर दूँ. हाँ, किस डायरेक्शन में? एरो बनाओ, डरो मत. यू हैव इरेजर, डस्टर है. दैट्स द डायरेक्शन. और वो 4.9 वाला वैसे. ये क्या वर्लपूल है? ऐसे ऐसे घूमता रहेगा पानी. बोलो. सोचो. That is the rate of flow. That is the permeability. That is the hydraulic conductivity. That's a separate thing. So there are two things here. One is the direction of flow, and the other is the rate of flow. The rate बोला तो बाद में आएगा. पहले direction बताओ. How will you get the direction of flow? Come on. Right. You got the first word right here. Absolutely. Let's have a. Thank you. Better. Don't feel anything about this. You know, this is a class, and it's good for it's for us to learn. Okay.
The water will flow from the total high pressure.
Okay. What is that line? Okay.
These are the lines having same magnitude of particular line. Water will flow from these two. By using one flow net and the hydraulic gradient permeability the
Right.
rate of the water equals to Pi equals to AV.
Right. So the question is, I've given you some data. Tell me the answer. And you are right. You're absolutely right. So now show how that thing will work. Right. Put the numbers 5.2, 4.9. लिखो कुछ तो लिखो. You erased it, right? 4.7. Yeah, whatever. Right. Right. Now. And how much is the total pressure there? इतना करने का जरूरत नहीं है. You're right on track, but you don't need to do any of that. Let me tell you what you have to do. So this is 4.9 meters. Okay, this is 4.7, this is 5.2. I said 4.5.2 from the top. You are following me, right? Can you see from back there? You want more light? Okay. So it's 5.2 from the top. If the bedrock is 10, this is what? 4.8. Okay. So this is, I'll write 4.8 meters. Okay. This is 4.9. So this is 4.9. Sorry, 5.1. Sorry. Right. And this is 5.3 from the bottom up. Okay. So now think of it. Here I've got a water column of 4.8 meters. Here I've got a water column of 5.3 meters. Right? Here. Okay, na? And here I've got a water column of 5.1 meters. So now what I'm going to do is I'm going to join this thing here, join this here, and join this third one here. Okay? Now 4.8 and 5.1. So I'm going to split it here, 4.9 and 5.0. Okay? It's a linear split. I've got 4.8 here, 5.3 here. So 4.9, 5, 5.1, 5.2, 5.3, 4.9, 5.0, sorry, 5.1, 5.2. Okay? Got it? Okay? And this is 5.3, 5.1. So this is 5.2 here. One middle point. Okay? Now I will join the equipotential lines. So 5.2, 5.2, 5.0, 5.0, 4.9, 4.9. Yeah. Now it is flowing from 5.2, 5.1, 4.9. This direction. Okay. Now remember, I came up with these numbers just like that. So this is how it will be. If you want to know the magnitude of it, this is 5.0, this is 5.1. Okay? So 0.1 head difference between this line and this line. And this is the distance, length. Right? You can find out the, yeah, you get the potentials.
Like here, say that you have made a well, and then but if you need to do that, then we will add that
Right.
soil.
Right.
In that case, we not do the
Right.
if well, we can also find
But
out.
if you don't know the number without a well. You won't know this height without a well.
All the points.
Right.
But if I know the height of the water table at a point for only one well.
How will you know the water table at a
Only
point?
one well. I am doing only
One well, so you cannot find the direction.
no, not direction.
Or
I know the water table, height of water table.
right,
That,
right,
then in that
correct.
find out that.
Hmm.
And then it
Right.
compute it.
Right.
We are using three wells because by using two wells there is only way straight line. Three wells, that's only 3D diagram.
Yeah,
Then
you
we
need
can
that.
make for the whole plate.
Yeah, you need that. You need a minimum of three.
Minimum of three,
Otherwise,
and then we can do it for as much as more than three.
minimum of 3 wells. Yeah, if you get 5 or 6 wells, you instead of having a triangle, you will have a hexagon or a pentagon or something. But then you continue to join. You'll get much more, much better accurate. Much more. Thank you. That is good. So you see now how we can get the groundwater direction and groundwater flow. Is it clear? So sediment sampling. So you should sample both upstream and downstream of property. So if there is a little creek or a small water body that is flowing through your site, you should sample upstream. Why do you need to sample upstream? Because you want to find out whether it is coming from somewhere else or it is a problem of that site. right? If it is coming from somewhere else, it is somebody else's problem, in which case you have to chase the other person down. You don't have to, it's not your problem per se, okay, or a problem that you have created rather. So non-intrusive testings, we talked about GPR, EM, ERT, seismic models. The intent is to find out tanks, objects, salt, underground contamination plumes, and so on, right? Like something you see here. Intrusive testing is where you actually drill a hole. The manual samplers for superficial soils, mechanical core samplers for at depth soil, vertical and horizontal delineation, sampling, handling and analysis, chain of custody. The other thing is the accreditation of the labs. Now, do you have a system here where the laboratories are accredited? You do, right? So you need to make sure that the lab that you're sending your sample to is accredited. What is the difference between an accredited and a non-accredited lab? It's certified. And what is the certification based on? Is based on the fact that they actually, that their process is that they have a very clear process of handling, analysis, reporting and all that. Always, if you happen to send samples to a lab, always find out whether you are certified or not. If it is not certified, then you should never send a sample there, because even though it's a lot cheaper, just because you don't know what they did with the sample, right? And at the end, everything depends on the results that you get back. So, chain of custody. Chain of custody is typically a concept that is really clean. At any time, one person should be responsible for the sample, and that person should be identifiable. So मैंने laboratory में sample भेज दिया is not good enough. You have to say, I gave the sample to person A in the laboratory, or somebody received the sample. Now from within the laboratory, that chain of custody moves on from that person A to whoever. Okay, because otherwise the chain of custody is already questioned. If you say I sent it to the lab and then the lab, nobody knows where it went in that lab. Data analysis and interpretation, even so much so that when you actually have a notebook for keeping your data, your notebook should be a hard-bound notebook, not a coil-bound notebook that you have, because you can rip papers out from that notebook, or people can think that you can rip papers out of the notebook. It's preferred to have a hard-bound notebook. If you find that so you take that hardbound to your field and you note things down, right? And if you write something wrong, let's say instead of writing 25, you wrote 75, and you realized it, right? You're supposed to scratch it off and write 25, and initial it and write 25. Mistakes happen, but if you erase it, nobody knows 5 years later whether you erased it at the time when it was questioned or you erased it in the beginning, right? So if you have erased it, then they will say, oh, you erased it and you made your 25 be 75, whereas that was actually 25. All kinds of questions come around. So that's why the protocol says, if you have made a mistake, scratch it off, say what it is. Maybe you made a mistake, it should be 75 or whatever it should be. Okay? So be very, very clear about these things. It is there is a lot of responsibility that rides on your shoulders if you are in this. Data analysis and interpretation may be iterative. Iterative means okay, so you do some sampling, you send it to the lab comes up with some results, and now you may find that let's say I sample this floor area, right, and I find nothing here, something there, nothing there, something here, something here. Okay, so I find that it's a mixture of data. right? Now, I want to see whether the nothing was just because I sampled, the sample I picked up had nothing, or is it because, on the other hand, the sample I picked up had something. You see what I'm saying? Like, which one is true? If you had couple of nothing and then a couple of, you might have, for example, you might have happened to pick up a scoop of salt sample that had something in it, right? It may not be a representative of the entire site or the entire room. So that's what you mean to, you have to do a complementary, or sorry, further sampling. Where am I? Okay. Okay. Sorry. So the soil sampling purpose and scope. Whether remediation is necessary is groundwater contamination. Is groundwater contaminated? The design of a program, the historical and current land use, sampling methods and equipment all have to be recorded or thought through. Sampling design objectives, identify sources of potential contamination, characterize nature and extent of contamination, determine whether it exceeds criteria, background. You also have to have the background. Okay, you might find that your soil has high concentration of X, but is that X coming from the activities that went on there, or is it coming because naturally the soil in that area has a high concentration? So you need background. So the background is typically upwind from that site, maybe a kilometer upwind, whereas it's not carried from here downwind. Okay, you need that background information, because if the background concentration of that particular thing is high, then that will explain why you are finding high concentration and not necessarily activities. You should identify and delineate hotspot. You know what a hotspot is? Is where you find high concentrations. In a large area, you may find very high concentration of certain things in certain locations because there were some activities that went on there. Okay, that's a hotspot. So delineate the hotspot. Find what are the limits of the hotspot. Okay, because you don't want to clean up the whole site, just the areas that require cleaning. Okay. So stage sampling, there are two-phase sampling. Phase 1, taking samples in one survey. Phase 2, limited sampling plan to determine presence, absence, variability at hotspots. So when you budget this thing, you have to always keep some money aside for supplemental analysis. So at least the 10-15% of the budget, you should keep it aside, thinking you will have to go back and resample. Because when you send to the lab, you will be surprised how you will be surprised how often you will get surprised with the results that come back from the lab. Okay, so in phase 1, okay, so this is the sampling. We are not talking about the phase 1 we did before. In the sampling stage, you take samples in one survey, and your first survey can be one of these methods. You can say a grid sample. You can say, okay, I'm going to divide it into grids, and I'm going to sample the center of every grid. That's one way of very standard sampling called grid sampling. No bias, nothing. It's just what it is. Okay. You can also use a stratified sampling. You divide the sample into smaller areas and strata, and then sample from them. Okay. You can the other thing is you can do judgmental. Judgmental means the phase 1 reports that there is distressed vegetation there. I'll do sampling there. The phase 1 report that there were drums there. I'll do sampling. I'm not going to sample the whole site. That's judgmental. Typically, the judgmental is the one that has the least number of samples, but you might go wrong. Your judgment it's judgment based, right? The random sampling is you take a large number of samples fully randomized. Okay, so there is the different ways of sampling, different ways of how you design the sample. This is the sampling program. Whatever you design, you're hoping to capture the contaminated area. Okay, whatever method you choose, whether it's judgmental, whether it is even if you use judgmental, it's not a bad idea to use to do some sampling in areas which you don't think are contaminated, just to get some background levels, maybe to make sure that your judgment is in fact true. Okay. So in the first phase of it, you will sample all of them, judgmental or random or stratified or whatever. Okay. Then you will come back and do a limited sample to determine presence, absence, variability, and hotspots. Okay. You found something somewhere, you want to make sure that that is indeed what is finding. Okay. And you have to consider both vertically and horizontally, surface wise and also on the depth. So okay, now this is the other thing. So you have to also think about sampling procedure. Discrete sampling, which is I have a scoop, I take a sample, send it to a lab. That's okay. Then you can also do what is known as a composite sampling. A discrete sample is I take a sample, I send it to a lab, I measure it, but you're only getting what in that sample. Okay. You might choose to do what is known as a composite sampling. Composite sampling is I take sample, 6 of them in this little quadrant, and I mix them together and I send it to a lab. Okay. There is an advantage and a disadvantage of it. The advantage is the cost of analysis is lower because you're only analyzing one sample, even though there are 6 of them, right? The disadvantage is dilution or basically homogenization, right? So yeah, so you can use, and it's not permitted for in situ characterization. It can be used as an initial screen in uniform areas and cannot be used for delineation of volatiles. Composite sample, because you mix this and volatiles will go away by the time you actually get the compositing done. You're mixing it well, the volatiles will volatilize away. And cannot be used for confirmatory sampling. Confirmatory sampling is I want to confirm something is present or not. If you mix it, it'll average out, and then you will think it's not there, right? Because in confirmation you are trying to confirm something is happening or not. But if you dilute it out with some other samples, it'll go away, right? Sampling from soil piles needed to ensure proper depth representation. Randomized samples with sampling from hotspots. Decontamination procedures to prevent cross-contamination. And I was talking about this earlier, the sampling equipment to remove organics. We have to use a methanol wash and drilling and other equipment. You have to make sure they are decontaminated. So you are not doing any cross-contamination between samples. Sample handling and preservation. So soil samples, there should be no headspace. Quickly transported. Organics with low regulatory limits, use only stainless steel sampling device and no latex gloves, because the latex will absorb the low regulatory requirements means which are regulations require very low numbers. Anything above that very low number is contaminated, right? If you use latex glove, the latex glove will absorb it and it will go below criteria. Are you with me in that? No chrome plated device for metal sampling for obvious reasons. Sample containers and preservation, glass containers for organics, glass or plastic for metals and organics, and volatiles require special sampling and preservation. So So groundwater sampling, you have to again come up with purpose and scope. Determine the quality of groundwater. Determine whether the quality of groundwater meets the guideline. The direction and rate of flow talked about. Determine the source of contamination and assessment of off-site contamination caused by on-site activities. Right. So let me see. Where am I now? So stratigraphy and groundwater flow direction, hydrogeologic characterization. The purpose of groundwater, if you're doing sampling of subsurface, you want to achieve multiple purpose with it. Okay, you want to get the samples, soil samples, you want to get groundwater samples, you want to actually understand how the groundwater flows, measure the groundwater table, you want to understand how the groundwater flows, which direction, what is the flow gradient, all that you can capture with the same system that you are going to use for subsurface soil sampling. Because you're drilling an auger, you might as well collect samples in the unsaturated zone, might as well collect samples from saturated zone. And if you're collecting samples in the saturated zone, might as well collect some water samples. Okay, so there are ways to measure the hydraulic conductivity. Do you know what a hydraulic conductivity is? What is hydraulic conductivity? Yeah. The ease with which water flows in the soil. Anyone else wants to? Rate of change of water level. Okay. Anyone else? I agree with both of you, by the way. In a way. Anyone else? If I ask you a question, especially the two of you who answered, what is porosity? How will you define porosity? Yes. So is it the speed with which water is moving from within the spaces? Is hydraulic conductivity the speed with which water is moving? When you say the ease, what exactly is the meaning of the word ease? I understand that the porosity part. What do you mean by ease with which water is moving? Yeah. Is the velocity of seepage the same as hydraulic conductivity? So what is the unit of hydraulic conductivity? Centimeters per hour, right? So distance by time. What is the unit of velocity of seepage? Huh? So is it the same unit? So then So the hydraulic conductivity you said is distance by time, which is the same unit as velocity. So what is it? What is it now? You right? Both of them have the unit, the unit of speed, meters per second, right? Then what is the relevance? What is the hydraulic conductivity? Whenever I see meters per second or that units, I start thinking of something moving at a speed. You say seepage velocity also has the same unit, right? So then which of this actually represents with which the water moves? Huh? Seepage velocity. So what is hydraulic conductivity? This is a trick question. So my question is a trick question, and that is why we all struggle with the term, because the origin of the word hydraulic conductivity is in Darcy's equation. Now Darcy in the mid 1800s conducted experiments. So you should look at the screen at the top there and see that Q is equal to KIA, right? So Darcy conducted an experiment with a sand pipe like this. So if you have a pipe filled with sand and if you have water flowing through this, right? Okay, Darcy conducted an experiment and found that the flow that goes through, okay, is proportional to the area is, and this is filled with sand, okay, by the way, and it is proportional to the hydraulic gradient, which if I put a standpipe in these two ends, the difference between the standpipe height, which is given as height, difference between the standpipe divided by the length. Are you with me on that? All of you? Okay. So Darcy found this proportion, the Q is proportional to Q, and so in order to make it useful, he came up with this equation, because Q is equal to K, which is a proportionality constant, IA. This is your hydraulic conductivity. It just happens to have the same unit as meters per second, because this is meter cube per second and this is meter square. So this one's unit happens to be the same as meter per second. It is not a representation of velocity of anything. Okay, so that is why everybody struggles with explaining hydraulic conductivity, and that's why when I said what is porosity, you can easily explain it, because you can see at the back of your head there are pores, there are spaces, there is the sand, and porosity you can divide by volume of pores by total volume. I get this porosity, right? Hydraulic conductivity, not that case. Think about what you're getting when you think about hydraulic conductivity. You don't. You try to think about, okay, there is a pipe, there is this, there is that, because its origin is in as a proportionality constant in Darcy's equation. Okay, the seepage velocity is given as K times I divided by N, which is the porosity, and that is the average velocity with which water flows in the pores. So the seepage velocity, V seepage, is K I divided by N, and there is a negative sign. Oh, there's no negative here, but there's negative sign here. But Ki by N, which is this is your porosity. Okay. So next time somebody like me asks you explain the physical form of hydraulic conductivity, you should say it's a bad question. Okay, I'm going to skip this, and I'm going to skip this, and I put this one here, and I'm going to stop here.